So I want to call f a function from a to b. I'm going to call it 1 to 1. You'll also hear the word injective, so 1 to 1 injective. If whenever f of x1 equals f of x2, then you can conclude that x1 is equal to x2. And we'll call f from a to b onto or surjective if, in shorthand, if the image of f is b. That's what it means to be onto. More specifically, i.e., for every little b in big B, there exists an a in A such that f of a equals b. And so you guys played around with this quite a bit in discrete, and it's certainly some ideas we're going to need as well. So onto surjective means everything in B, everything in the codomain gets hit. 1 to 1 you can think of as unique inputs. Different inputs have different outputs. If the output is the same, then the inputs have to be the same. All right, so what we'll use those ideas. We're going to need those. We're going to actually talk about bijections, which you might remember. A bijection is a function that's both injective and surjective. I didn't leave room to write that here, but you might want to scribble it down, although I'll write it down later when we need it. So what we're interested in is a function f from x to y, and I want to pick a subset of the codomain. Okay? So then the preimage, or some books will say the inverse image. I'm always going to say the preimage. The preimage of B it's a set, and it's the set. Let's actually write that. It's the set, and we write it like this. Now that looks like f inverse, but it's not, because I don't know that f is 1 to 1. F does not need to be 1 to 1 to talk about preimage. So this is not saying 1 to 1. It's just the set, preimage of B. It's the set of x in X such that f of x lands in B. Does that make sense? So if you want to draw a picture, here's B, and here's maybe your larger set Y, and over here, back here in X, the preimage is all the stuff that when you plug it into F, you land here in B. So you're in the preimage if and only if F takes you back over here to your set B. So we're going to be working with the preimage quite a bit. We're going to care very much about some of its properties. The image of A, that's a little easier. So here I'm picking an A in the domain. The image of A is exactly what you think it should be. It's the set f of A. It's the set f of x such that x is in A. So you've got what you need to do the homework from the section I just assigned you to, problems 1 and 3. We'll combine this homework with 3.2 as well. So I'll stop this video here, and then we're going to go on and look at just two theorems in the next section. And we won't prove all of them. We'll just prove parts of them. But that's it. So next section.